Good morning, boys. In the last lesson, I have discussed the concept of limits and continuity. And today I will continue with this continuity. Right? And what we have learned that a function f of x is said to be continuous at any particular point a if limit f of x tends to a plus is equal to limit f of x tends to a minus is equal to f of a. That means this one is your RHL, LHL and the value of the function at the point A. If this is equal, we say that it is continuous. This we have discussed in the last lesson. Now, today I will be going just to discuss some of the concept of the continuous function. Let f and g be two real functions which are continuous at a real number c. That some property you have to write. That is called the properties of the continuous function, or we can say in the book edition that algebra of continuous function. Algebra of continuous function. Algebra of continuous function. Right? Let f and g be two real functions. Let f and g be two real functions which are continuous at any particular or any real number c. At any real number c. Then we have the composition, or we can say that the f plus g is continuous. Then the function f plus g is continuous at x equal to c. Second, f into g is continuous at x equal to c. Third, f by g is continuous at x equal to c provided g is not equal to 0. The function g of x is not equal to 0. The fourth, f minus g is also continuous at x equal to c. That means if the two functions f and g are continuous at any particular point c or at any real number c, then their sum f plus g, f into g, and their division f by g and f minus g is also continuous. Please note down this point. And next point, we'll notice now that now point D. Each and every rational function is continuous. Each and every rational function is continuous. Every rational function, if you write f of x equal to 2x plus 3, 3x plus 4, 3x minus 5, something like that. That's why every rational function is continuous. Similarly, each trigonometric function are continuous. Each and every trigonometric function like that sin x, cos x, tan x, sec x, cosec x, all the trigonometric functions are also continuous in the domain where it is defined. Each trigonometric functions are continuous in the domain where these functions are well defined. Right? These are the properties. For example, if I write here sin x, y f of x is equal to sin x. F of x is equal to sin x. Now see, do you remember the graph of the sin x? Yes or no? See, now it is a continuous function. There is no breakage in the continuity in the graph of the y is equal to sin x. Right? Wherever these functions are defined in the particular domain, we know that they are domain elements, and wherever they are defined all the trigonometric functions, they are continuous function. Right? Now I am going to solve some of the questions of your exercise. For example, the first question of exercise 5.1. Let's see the exercise 5.1. See the first question. In the first question is given that prove that the function f of x is equal to 5x minus 3. Given function f of x is equal to 5x minus 3 is continuous at x is equal to 0, x is equal to minus 3 and x is equal to 5. So first of all I will check that at x is equal to 0. And the given function is f of x is equal to 5x minus 3. Now, limit of f of x, x tends to 0 is equal to what? 5x minus 3 is equal to 5 into x tends to 0, 0 minus 3 is equal to minus 3. And if you find the value of f of x, where x tends to 0, right? And if I put the value f of 0 at x equal to 0, suppose I have 9 now, that means limit of the function f of 0, then also you get 5 into 0 minus 3, that is equal to minus 3. I can do in this step also. Here minus 3 and minus 3 both are same, right? But I'll suggest you go for this so that we'll have the complete practice. You check it at the point 0, 0 plus, 0 minus and at 0, and then we'll go for solution, right? So therefore I'll rub it and then I'll go for my at x equal to 0. First of all, limit f of x, x tends to 0 plus, means what? Limit f of x tends to 0 plus, that means just more than 0 plus h, and limit s tends to 0. Now this is equal to limit s tends to 0. Now x will be replaced by 0 plus h. X will be replaced by 0 plus h. Wherever we have this, now 5 into 0 plus h minus 3. This will give you limit h tends to 0, 5 into 0, 0 plus 5h minus 3. Now s tends to 0. If I put here s equal to 0, this also becomes 0, and that equals to 0 plus 0 minus 3, and that is equal to minus 3. Now I'll find out the limit of the function at f of x tends to 0 minus. 0 minus means what? Limit f of 0 minus h tends to 0. The function limit s tends to 0, f of 0 minus x will be replaced by 0 minus h. I'll get here 5, 0 minus h minus 3, and that is equal to limit s tends to 0, 5 into 0, 0 minus 5h minus 3, that also becomes 0 minus 0 minus 3, and that is equal to minus 3. Now see the value, LHL and RHL both are equal. If I put f equal to 0 in this given function, that also I am getting here minus 3, and therefore LHL is equal to RHL, and hence it is continuous at x is equal to minus 3. By the way, before solving these questions, I made you to write one line that each and every rational expressions or rational functions are continuous. But for the checking at this any particular point, we can check it by this way. Similarly, we can check it at x is equal to minus 3 and x is equal to 5 also. Okay, now if I go for the another question, question number 3. In the question number 3, it is given that examine the following functions for its continuity. Examine the following functions for continuity. There are 4 parts, and each and every part, the first function is f of x is equal to x minus 5. Part B is f of x is equal to 1 upon x minus 5. Part C is f of x is equal to x square minus 25 upon x plus 5. And the part D is f of x is equal to modulus x minus 5. Now if you see the second part of the questions, B, f of x is equal to 1 upon x minus 5. Of course, x is not equal to 5. X is not equal to 5 because when x will be 5, the function will be not defined. That means being the rational functions is continuous everywhere. Any particular point is not given. That's why what I'll do, I'll check any real number C. Okay, let for any real number C. That is at any particular point C I will check. That is now I will find out limit of f of x tends to C plus. That is called what? Right hand limit. And that is equal to limit f of C plus, I write here C plus h, and limit s tends to 0. Now this becomes limit s tends to 0, 1 upon. Now x will be replaced by C plus s, then I write here C plus h minus 5. Now put s equal to 0, what I will get? 1 upon C minus 5. Now I will find out limit of f of x tends to C minus, that is equal to limit f of C minus h s tends to 0. Now limit s tends to 0, 1 upon x will be replaced by C minus h. Now C minus h minus 5, again put h is equal to 0, what I will get? 1 upon C minus 5. See now the value of the given function f of x at any real number C, their RHL and LHL both are same. Here the right hand limit is equal to left hand limit, and hence if it is continuous at any particular point C, it means it is continuous everywhere. That's why the question was, yes, examine the continuity of this given function. That's what I write. Yes, the given function function is continuous at any real number, right? Similarly, I think the part C, if I go for part C, the part C, the question is f of x is equal to x square minus 25 upon x plus 5, where x is not equal to minus 5, because you know that again if I put x equal to minus 5, this whole functions becomes not defined. Okay, now for the gain any particular value is not given, that's why let any real number c. Now I will check the limit of this given function f of x as x tends to c plus right hand limit is equal to limit f of c plus h limit s tends to 0. This is equal to limit s tends to 0. Now x will be replaced by c plus h. So now c plus h whole square minus 25 upon c plus h plus 5. This is equal to limit s tends to 0, c square plus h square plus 2ch minus 25 upon c plus h plus 5. Now wherever you find h, you replace by 0. Then we will get here limit h tends to 0, c square minus 25 upon c plus 5, and that will give you what? C minus 5, because c minus 5 and c plus 5 will be factorized. C minus 5, c plus 5 upon c plus 5 cancel, and that is equal to c minus 5, right? If I will find out now the left hand limit of f of x, x tends to c minus, and that is equal to limit s tends to 0 f of c minus h, right? This is equal to limit h tends to 0, x will be replaced by c minus h, that means c minus h whole square minus 25 upon c minus h plus 5. This will give you again c square plus h square minus 2ch minus 25 upon c minus h plus 5. Either you replace here only h is equal to 0, that also we can do, and then I will get here now c plus 5 c minus 5 upon c plus 5. Now this c plus 5 is cancelled, again I am getting here c minus 5, and therefore what we get? LHL is equal to RHL, and therefore this given function is continuous for any real number c, and when it is true for any real number c, it is continuous everywhere, right? Now some of the questions I will solve. Now question number 6. The question number 6 is f of x is equal to 2x plus 3. F of x is equal to 2x plus 3 when x is less than equal to 2. If x is less than equal to 2 and f of x is equal to 2x minus 3, 2x minus 3 if x is greater than 2. That means there are two parts of this functions. It can be 3 parts, it can be 4 parts. Here you have 2 parts. See now f of x is equal to 2x plus 3 if x is less than equal to 2, and f of x is equal to 2x minus 3 if x is greater than 2. And we have to check the continuity of this given function. This given function is a rational function, and that's why we have mentioned one line that each and every rational functions are continuous everywhere. Of course it will be everywhere, but let me check at any particular point. Here it is given that 2, that means here the condition we have x can be less than 2 x can be more than 2 or x can be equal to 2. That's why here I'll check at the continuity of this function at x is equal to 2. Okay, now at x equal to 2, I cannot go directly on 2. What I will do, I have to go again left hand limit and right hand limit. That means limit of the given function x, f of x at x equal to 2 for the right hand limit. I will write here right hand limit is equal to x tends to 2 plus. So now this becomes limit f of 2 plus h, limit s tends to 0. Now limit s tends to 0 when we have f2 plus h, just more than 2, just more than 2. Now here we have two functions, we have to be smart enough. X more than 2, x is greater than 2, then I have to use this function. And when x is less than 2 or equal to 2, then I will use this function. Here it is already given that when x is greater than 2, then the function takes the value 2x minus 3. And when f of x takes the value 2x plus 3 if x is less than 2 or equal to 2. So now where I have taken here 2 plus right hand limit, that is more than 2. That means I will go for 2x minus 3. So now x will be replaced by 2 plus h. So now 2 in bracket x, 2 plus h minus 3, right? And that becomes limit h tends to 0, 2 to the 4 plus 2h minus 3. Now that is equal to 4 minus 3 and that is equal to 4 minus 3 and that is equal to what? 1. The limit of the given function x at x tends to 2 plus is 1. Now check the left hand limit. Limit of f of x, x tends to 2 minus is equal to limit f of 2 minus h, h tends to 0 is equal to limit h tends to 0. Now see 2 minus h less than 2, smaller than 2. I'll go for this first part of the functions 2x plus 3. Now I will get 2 in place of x, 2 minus h plus 3 and that is equal to limit h tends to 0, limit h tends to 0, 2 to the 4 plus minus 2h plus 3, I am getting a 7. 4 plus 3, h is becomes 0, 4 plus 3 is 7, here it is 1, here it is 7. If I check it for 2, f of 2, limit f of x, limit of f of x, x tends to 2, then for equal to 2, here this is the function, again I will get this is equal to 2 into 2 plus 3 and that is equal to 7. That means here no need to do this part. I can simply write now that LHL and RHL both are not equal. Here I am getting 1, here I am getting 7. Here LHL is not equal to RHL and therefore the given function it is not continuous at x is equal to 2. Except x equal to 2, it is continuous everywhere. That we can check it here. So now we have checked that the point of discontinuity of this function is 2, right? Therefore this given function is not continuous at x equal to 2. And now I will solve question number 7. In the question number 7, to mod x plus 3, f of x is equal to mod x plus 3 if it is given that x is less than or equal to minus 3 and the given function becomes minus 2x if x is less than 3 and greater than minus 3 right? And it becomes 6x plus 2, 6x plus 2 if x is greater than or equal to 3. See now, here we have two numbers, 3 and minus 3. That means we have to check the continuity of this function at two number 3 and minus 3, and for that you check whether we have the function defined for 3 minus 3 plus or 3 or not. If I have 3 less than 3, yes, x is less than 3. X greater than 3 and equal to 3 also there. If I check for minus, x is greater than equal to minus 3 and x is less than equal to minus 3. That is, both the numbers are there on which I can check. Therefore, first I will check for at x is equal to 3. I am just, suppose I am writing x is equal to 3. Now, limit of given function f of x, x tends to 3 plus, a right hand limit, is equal to limit f of 3 plus h limit s tends to 0, that is equal to limit h tends to 0 f of 3 plus h, that is more than 3, x greater than equal to 3, what we have 6x plus 2. Make it very clear from this given function. Yes, which part we have to use of the function. X is greater than equal to, therefore when x is equal to 3, then also I will check, go for this function. When x is also more than 3, I will go for 6x plus 2. I will write here what? 6 in place of x, I will write 3 plus h plus 2, and that is equal to limit h tends to 0. 6 is 18 plus 6h plus 2, and that is equal to almost 20, because this h becomes 0. The 18 plus 2, 20. Now, LHL, limit f of x, x tends to 3 minus, that is equal to limit f of 3 minus h, limit s tends to 0, that is equal to limit s tends to 0. Now see, 3 minus h less than 3. For x less than 3, I will use minus 2x. Now minus 2, and in place of x I will write 3 minus h. That will give you how much? That is the limit h tends to 0, minus 2 into 3, minus 6 plus 2h, and that is equal to minus 6. No need to find out at x equal to 3, because what we see that RHL is not equal to LHL, and therefore this function is not continuous at x is equal to 3. If LHL is not equal to RHL, and hence it is not continuous at x is equal to 3. Right? Now I'll check the continuity of this function at x equal to minus 3. At x equal to minus 3. Yes. Now, limit f of x, x tends to minus 3 plus, that means I am going for RHL. Now this is equal to limit f of minus 3 plus h, limit s tends to 0, and that is equal to limit h tends to 0. Now minus 3 plus h, that means what? Just more than minus 3, just more than minus 3. When it is just more than minus 3, x is greater than minus 3. See now which function we have? This one. X is greater than minus 3. When x is greater than minus 3, then what I will use? Minus 2x. Then I will write here minus 2 in place of x. I will write minus 3 plus h. And that will give you limit h tends to 0, minus 2 minus 3, 6 minus 2h, and that is equal to what? 6. Right? Now LHL. limit f of x, x tends to minus 3 minus, that is equal to limit h tends to 0, f of minus 3 minus h, minus 3 minus h, that is just less than minus 3. Now that is equal to limit s tends to 0, f of minus 3 minus h less than minus 3. When x is less than minus 3, then this function mod of x plus 3, I write mod of minus 3 minus h plus 3, and that is equal to what? Limit h tends to 0, minus 3 minus h, mod will be how much? 3 plus h plus 3, minus 3 and minus h, the positive value I will take, the 3 plus h plus 3, and that is equal to how much? 6. Right. Now if I will check at x is equal to minus 3, x is equal to minus 3, so now limit of f of x, x tends to minus 3, at minus 3, for x less than equal to minus 3, same function I have to use, and that is equal to what? Mod of x plus 3, and that is equal to what? X tends to minus 3, mod of minus 3 plus 3, that is coming 3 plus 3 is equal to 6. There will be what? Here LHL and RHL both are equal. Here LHL is equal to RHL, and hence it is continuous at x is equal to minus 3. The given function is continuous at x is equal to minus 3, but it is not continuous at x is equal to 3. Same way we can do almost all the questions of this exercise, and after that there are, I think altogether there are 34 questions are there. Right now I have done the questions till question number 7th. Similarly, we can go for question number 8, 9, 10, 11, 12, but my way of solving the questions is not going to help you out. Please you try your level best, and please you solve it, and if you are not getting, you will ask your questions also, right? And in the next lesson again I will do some of the questions, and that I will tell you in advance that the question which I am going to solve, that would be question number 17, 18, 20th, 21, 23 and 25, and then out of 26 and 30, question number 30 I will be doing, and question number 27. These are the questions which I will be solving, right? 17, 18, 20, 21, 23, 25, 27 and 30, right? This much questions I will solve, right? And I hope that you also try your level best, and if any query or any questions are there in your mind, please you feel free to ask. Thank you very much.